In this section, you solve rational equations. And a rational equation is an algebra equation in which there are fractions, and typically there are x's, or whatever variable you're using, which appear in the denominator. So I'm going to start off with a fairly simple one here. 3 over 2x minus 7 equals 1 over 3x. You have seen a rational equation before. In chapter 1, we had equations that involve fractions, but these fractions in chapter 1 didn't have variables in the denominator. So it gets a little more complicated, as you might expect. But we're going to follow the same principle, because in chapter 1 we cleared the fractions by finding the common denominator and multiplying every term by the common denominator. So here we're looking at denominators of 2x and 3x, and 7 is also a fraction. It's 7 over 1, but its one denominator is not going to help us as far as finding a common denominator. So between 3x and 2x, common denominator would be what? It would be 6x, wouldn't it? So I'm going to multiply this equation by 6x, which means we're going to distribute the 6x inside. So I'm going to rewrite it so it's very visual here. 3 over 2x minus 7 equals 1 over 3x was my original equation. And so when I distribute my common denominator 6x, then each term is multiplied by 6x. And here's a misconception. This number, even though it's not written as a fraction, is also part of the problem. You must also distribute the 6x so that it multiplies the 7 as well. So a number that's not a fraction is not exempt. When you multiply the equation, you distribute throughout the equation, every term gets multiplied by, in this case, 6x. All right, well, if you've chosen a common denominator, then what happens is that the denominators will all cancel off. You will clear the fractions. But our real goal is to find the least common denominator, because that produces the smallest numbers and the smallest powers of terms. 6x was the least common denominator here, as it turns out. All right, so what happens? Well, this x cancels, and 2 cancels with 6, leaving a 3. And there's a 1 left down below, but you don't always have to write that 1. Over here, x cancels, and 3 cancels with 6, leaving a 2. So we end up with 3 times 3, 9, minus 7 times 6x is 42x, is equal to 1 times 2, or 2. Well, happily, the fractions are gone. And that was the purpose of multiplying by the common denominator. It cancels off the denominators, clears the fractions. And so now we have a rather mundane looking problem to solve. I'm going to subtract 9 from both sides. I get minus 42x equals to minus 7. And then divide by negative 42. So x equals to, now look what happens here, the negatives cancel, and 7 does cancel in the 42, it goes 6 times. Actually, it reduces to 1/6. So 1/6 is our answer. Now, I want to check this answer. I want to show you the check. I'm going to make kind of a big deal about checking answers, because eventually you'll see why that there's a little more involved to these problems than meets the eye. And there are a few of these that you can encounter in which there is no answer. But we don't know that unless you check the answers. So that's the purpose there, one of the purposes. Besides, we like to know we're right. So I'm going to check this answer, and I need to make room on my board. Okay, so we have, here's the check. 3 over 2 times 1/6 minus 7 equals 1 over 3 times 1/6. So I replace the x's with 1/6. And how tough can it be? what is 2 times 1/6? Well, 2 cancels the 6, leaving 1/3. So I have 3 over 1/3 minus 7 equals 2. And here, this 3 is a numerator, cancels that 6, leaving 1/2. 1 over 1/2. Now, what is 3 divided by 1/3? 3 divided by 1/3 is, and what do? We invert and multiply. It's the same as 3 times 3 over 1, which is 9. So this number here is 9. 9 minus 7 is, and if you divide 1 into halves, there are 2 halves. 9 minus 7 is 2. So our answer is correct. X equals to 1/6.